Hello class, I hope you're doing well this week. In this tutorial video in week 6, module 6, I wanted to go through how to use the Excel solver algorithm that incrementally changes certain variables that you specify and then optimizes a target variable that you also specify. Now when I say optimize, it could be a minimum number, it could be a maximum number, so you will be specifying what you basically want the solver algorithm to do. So the first thing you will do is open the Excel spreadsheet that is linked to QSO-320 Module 6 Assignment Guidelines and Rubric, and then you will see the spreadsheet that is on the screen right here once you click on Module 6 Solver Part 1. So in this example, this is an ungraded example just to show you how to do the solver algorithm, how to use it. You'll see that it pertains to manufacturing and sales of tables and chairs. So the table set up here is the profit totals, C6 times C5, which is the profit times the number of tables they make. And then for chairs, profit is volume of chairs they make times the profit per chair. And here is the selling price of a table, selling price of a chair. And as you could see, it makes perfect sense. Obviously, that's a plugged-in number. That's a plugged-in number. This is calculated based on selling price minus the manufacturing cost. As you can see, B7 minus F15, and this is calculated as the selling price of a chair minus the manufacturing cost of a chair, which is B8 minus F20. Over here is the profit total, which is just simply this cell plus this cell. And the idea here, as the question stated, is to maximize this profit calculation by figuring out how many chairs and tables you should build in a given day based on the constraints that you specify. So we go down here, and these numbers are also given as how much metal tubing, plastic sheet, and fabrication minutes, 15 minutes, basically quarter of an hour, it takes to build a table, and then the same thing, metal tubing, plastic sheets, and fabrication minutes to build a chair. So you can see in each calculation, when you multiply out the quantity it takes to build a table times 0.1, you get these unit totals for a cost of a table at $65.40. Same thing for a chair. You multiply it out, the quantity required times the cost per unit, and then the unit total is going to give you the total it takes to build a chair. I'm not sure if your spreadsheet is the same as mine, but there should be a total here. I will go to auto sum. So a chair should cost $17.60, and then the profit on a chair should be B8 for the selling price of a chair minus F21, which is how much it costs to make the chair, and then the profit would be $17.40. Check your spreadsheet and see if you have those numbers. If not, this is ungraded anyway, so I'll use the accurate numbers. So I'm not sure where that cell total went. Nonetheless, now you know what the profit is per table, per chair, and now you're going to decide on your constraints. In the case of metal tubing, which is by the foot, they have put in here that there is a maximum of 1,200 feet of metal tubing that they are or can use in a day. So that might be based on their deliveries of metal tubing on what period of time. So 1,200 feet is the maximum. Plastic sheet, 700 square feet, is the maximum they want to use in a day. Fabrication is 480 minutes, which I guess that's in an 8-hour day. That would be one person for 480 minutes if one person was doing this work. Kind of arbitrary, but it works for this exercise. The minimum number of tables they want to produce is 4 per day. The minimum number of chairs they want to produce is 10 per day. So those are the constraints that this solver has to figure out the maximum profit that can be made in a day, and how many tables and chairs you want to produce to maximize that profit, as long as you don't exceed these constraints. So one thing you want to make sure of is that the formulas in these constraints are correct, because remember, Excel doesn't know anything other than what you tell it. So these all have to be formulas so it knows what it's changing in order to maximize profit. So basically it's going to be changing the volume of tables and the volume of chairs to maximize that number, and that's all the solver is going to do, and I'll show you how to specify that. That means the metal tubing needs to be a formula based on C5 and D5 and what the amount it uses per. And then you can study that formula for a second and realize what it's doing. It's calculating all the metal tubing for table and chairs times the number of chairs you make. Plastic sheets, same thing. Study that formula for a second. You see it's multiplying out C5 and D5 volume of tables and chairs times the amount of plastic sheet square footage that it needs to make a table and chair. Fabrication, same thing. Number of tables is just pulling from C5 and D5 directly. So as you can see, the important numbers here are here, here, and calculating here. Now, you could do this manually. I mean, you could go plug in here and say, okay, I'm going to assume I'm making 5 tables and I'm making 12 chairs. Boom. Tells me how much material I'm using, tells me what my profit is. And I could say, what if I made 10 and 18? Okay, profit went up. I'm getting closer to my constraints here with 400 feet, 214 square feet. But you can see how tedious this would be to maximize your profit by using as much of this material in a day and not exceeding any of the constraints. So that's what the solver does for you. So let me put these back to 0. I just wanted to show you basically what solver is doing automatically is what I just did manually. So that's why your formulas have to be correct, because solver isn't, it's a Monte Carlo program. It's not a statistical analysis. So it's just going to tweak this and this to maximize this and use up as much of this as it can without exceeding any of the material available or the labor hours available. So with that being said, I will go into data. I will pull up the solver screen and I will say let me pull it over here. What is my objective? My objective is basically that number right there, maximize profit. And I want that to be a max. Sometimes some mins you could use an actual value you're trying to hit, but it's profit, so it makes sense you want to maximize it. Now, what variables am I going to change to get there? Well, I'm going to change the number of tables I make. I put a colon, and I'm going to change the number of chairs that I make. So C5 and D5 are going to be the variables that I am going to change. Let me slide this over. It's in the way. And my constraints are going to be cell reference metal tubing. That's calculated here, and it's going to have to be less than or equal to 1200, as it says there. So I click OK. and I add another one, and I say I want plastic sheets calculated here to be less than or equal to that number, 700. Okay, so far so good. And then I want my fabrication hours here to be less than or equal to 480. So far so good. And keep on going. I also want the minimum number of tables to be 4. So this has to be greater than or equal to 4. And I want the minimum number of chairs calculated here to be greater than or equal to 10. So now I've set up my solver parameters right here. So basically says to maximize E4 by changing C5 and D5 and remaining within these constraints, what's the maximum profit I can get using up all the material that I have for a day. Okay, I'm sorry I had to pause for a second. My video screen recorder here went crazy and changed the size of the box, so I have to change the size of the spreadsheet to fit in that box, but I'm back. So as explained prior, these are the parameters and the constraints, and the next thing you would do is hit solve. And you'll see a box pop up for the solver results, and you'll see that, let me say keep solver solution and generate reports, answer, sensitivity, and limits. And what it's going to do is generate additional tabs on the spreadsheet. But I want to show you what it did. It said that based on hundreds of iterations, don't know how many, but that it said that 4 tables, 105 chairs per day would generate the maximum profit and would be within the constraints. So 1,138 feet, 379 square feet, 480 minutes. You would basically generate the bare minimum number of tables and 105 chairs. So that would be the answer that it came up with to maximize the profit. So that concludes part 1 of the exercise and leads us into part 2 and 3, because we already said to select it to generate the sensitivity report and the limits report. So I will go to the additional tabs that it created. So I come down here and I click on the answer report. And basically what it does is tell you in a report format that you selected E4 for profit totals, had a 0 in the cell, final value $2,000. As the part 1 tab said right here, basically it's just taking data that it used and how it solved the problem. The variables, 4 tables, 105 chairs with these constraints, and what it used out of the value of the cell based on the constraints. And that is basically what the report looks like. Now what the sensitivity, or let's do the limits report. The limits report basically shows you what your target objective was, and the fact that you did 4 tables and 105 chairs, and what the profit was for each of those. The same with the sensitivity report right here, telling you what the final values were of the cells and some other parameters that you are welcome to look up to see what they mean, but they're not part of this course content, so you're not required to understand that. That would be for a future date in an advanced Excel solver class. So for part 3 of this exercise, I will go back to the original data, and part 3 says, what if management decides that they want to try 600 minutes of labor in a day. So basically what you're saying is you're going to change fabrication to 600 as a constraint. And then it says they've also increased minimum number of chairs from 10 to 16. So you change that to 16, you're changing your constraints. What else? Run solver again. Okay, so we bring up solver and it's using the same data and we run it again. And it's going to come up with a different maximized profit, which makes sense because you're running an extra 2 hours in that day. You're going 10 hours with one person instead of 8 hours, so you figured you'd be able to produce more. So now it says that the volume of tables is 19, the volume of chairs is 77 as a minimum, which obviously you want it to be over these two numbers that you specified. Now you've used up all your metal tubing and not quite your plastic sheets, and of course you met your fabrication hours. So this simulation had to stop because your metal tubing was done, but luckily it still used up all your fabrication hours in a 10-hour day. So it's an interesting result. Now 3B of this exercise, now imagine too many tables have been rejected. Production line for tables will be slowed down to basically to increase yield, increasing fabrication time to 26 minutes on tables. So you go in here and you say, okay, it's no longer 15. It's going to be 26. And then it says, however, management also found a way to decrease fabrication time on the chairs to 3 minutes. So I'm going to reduce this 4 to a 3. And now I'm going to run solver again with the same parameters. And it now says that I'm back to 4 tables because they now take longer to build, 26 minutes each, 112 chairs since they're very quick to build, and their cost per chair is much lower. So you would assume you're going to build more chairs as long as the profit is good on a chair, which it obviously is because table's $19.60, chair's $21. And you can make many more chairs in a day than you can make tables. So that's what this data is saying. So number 4 says, use the tab labeled Solver 4 to complete the following. Create and program spreadsheet with data based on the following scenario. Okay, and that's the homework assignment that is created. So basically this is how you do the example assignment. If you don't get overwhelmed by it and you just keep in mind that all you're telling it is what you want to maximize, what variables you're going to change, and what variables you're going to hold as constraints. But you need formulas for this so that when Excel changes this and this, it knows what the resulting number is that it's going to compare to the constraints. It would have no other way of knowing. So in doing the assignment for this, just keep that in mind, is that you have to have these formulas in place so that as the solver changes parameters, it knows what the result of that change is. So imagine you're doing it manually and then let solver do it for you automatically. Okay, thank you very much, and I hope this helps for this week's assignment.